All right, so good morning, students. We will do this question on the topic of friction. On the face of it, this question will look very easy. So I will discuss why it looks very easy to you, right? Because I have been through this whole process of preparation of the exam. I know many questions look very innocent, but are tricky. So let's read the question first. Before that, don't forget to subscribe to this channel. Very exam-like questions, detailed understanding, explanation of the concept. You can see solutions on the website, but you will never get to know why they have done this. Right? They just write something. So dumb websites or dumb videos with no explanation are useless. So subscribe to this channel to get clarity. More clarity you get, less stress you will have, and more marks you will be able to score. Let's now worry about this question. This is a block of mass which is lying on a horizontal surface. There is a coefficient of friction which is given to you. The question is, what is the minimum force to be applied on this block for it to move horizontally, right? So most of the students I've worked with, right, have this confusion in their mind because they get so accustomed to doing questions on friction that their instant impulsive answer is that the force of friction that should be applied, right? What is the minimum force you need to apply, right? So you will say mu into mg, right? This is a standard answer. We know the mass of the block is m, and therefore the normal reaction is equal to mg, and this is the answer, right? Really speaking, yes, to an extent, the thought process is correct. The normal reaction is equal to mg, right? But if you write the force of friction, okay, the force of friction is written as mu n. It is not to be written directly as mu mg. Though writing mu mg is very, very tempting, and I will tell you the reason why. The reason is force of friction is not dependent on weight of the body. It is dependent on the normal reaction. Something which is dependent on normal reaction, you should actually prefer writing this expression, right? Then the question arises, what's a big deal if you write mu n, right? N is, after all, coming from mg, right? But we can think of a strategy where we would like to reduce the value of n. Yes, we can reduce the value of normal reaction even though the weight is mg, right? So this is your mg and the normal reaction is mg, okay? How do we do that? I will just read the question for you. We have to find the minimum force required to move this block horizontally. Everybody is tempted to write this. I am telling you, wait. Do not write it as mu mg. Please write it as mu n. And I'm saying now, force of friction is proportional to normal reaction. Remember that. It's not proportional to mg. It's a coincidence that it comes. What is the point I'm trying to drive home? The point I'm trying to drive home is very simple. Can I do something to reduce the value of normal reaction? If my friction goes down, my minimum force requirement goes down. How do I reduce normal reaction is the worry now. Let me show you a situation. Let's say you have the block here, right? So this is the block. Ideally, you would love to impulsively, apply a horizontal force F is equal to mu mg and say, I have overcome the friction. And now I will start moving, right? I have overcome the limiting friction. What about this? If I say you apply the force F at an angle theta, okay? So this is a big deal. Why? Let's take components, right? So the component number 1 is F is sine theta. The component number 2 is F cos theta, right? So this is F cos theta. This is F sine theta. Let's write the equation now, okay? The vertical motion direction, right? So you have normal reaction upwards, so upward normal reaction plus f sine theta is equal to mg. So normal reaction becomes mg minus f sine, right? The normal reaction reduced because you applied a force at an angle. What is a horizontal force? The horizontal force is F cos theta acting on the body is equal to the frictional force, which is mu into N. So F cos theta is equal to mu mg minus F sine theta. If I open this bracket, I will get F cos theta is equal to mu mg minus mu F sine theta, right? So F cos theta plus mu F sine theta is equal to mu mg. And therefore, F is equal to mu mg upon cos theta plus mu sine theta, right? This is a general expression of the force you will apply to reduce the normal reaction. But what is the question? I have to minimize this. I need the minimum value, right? Now comes the mathematics. How do you find minimum value? Apply maxima and minima. So let's say I take derivative of this df by d theta, right? Instead of applying at some angle, I'm applying, horizontally, which was my impulsive reaction. I am applying it at some angle. Let me find out what is a force and d theta relationship, right? df by d theta. Rest is mu is known, m is fixed. The only derivative you could take is only this, right? So let's say this is mu mg upon, so this will become cos theta plus mu sine theta square multiply by, right? It will go up. Now I will take derivative, right? So minus sine theta plus mu cos theta, right, is equal to 0, which means mu cos theta is equal to sine theta and mu is equal to tan theta. That means your theta has to be tan inverse mu. If the theta is tan inverse mu, okay, take a double derivative also. Put tan theta is equal to mu. You will get this to be a positive number for obvious reasons. Then, if a double derivative, which is d square f by d theta square, is greater than 0, then f corresponds to minima. Right? That's a basic theory of maxima and minima. If you don't understand that, I have live lectures recorded on maxima minima theory and practice questions from mathematics. Go and watch it. Also, in the playlist Maths for NEET students, the explanation of this concept of maxima minima is given. Okay. Now theta is equal to tan inverse. So I will just draw a triangle saying that this is my theta, this is my mu, this is 1, this is under root of 1 plus mu square. So sine theta is equal to mu upon under root of 1 plus mu square. And cos theta is equal to 1 upon under root of 1 plus mu square. Right? So sine theta and cos theta are known to us, right? Now, what is the value we are supposed to put? Let me put the value of sine theta and cosine theta here, right? Finally, this is the theta for which force is minimum. So I will put this value here. Let me just write it here. You have space here, right? So my force is equal to, right? My F was written, right? This was my F, right? So F minimum is equal to mu mg upon, what is cos theta equal to 1 upon under root of 1 plus mu square. And what is my sine theta equal to? My sine theta will be equal to mu upon, right? So this will be uh, f cos, f is equal to cos theta plus mu multiply by mu upon under root of 1 plus mu squared. So this becomes mu mg into under root of 1 plus mu squared divided by 1 plus mu squared. Cut it and you will get mu mg upon under root of 1 plus mu squared. That's your F minimum. So this is, you can see that mu mg is very different from the instantaneous answer you gave. Right? You initially the thought process was, we were tempted to write it as mu mg, pull it horizontally and finish it off. No, actual answer is the minimum force required to move this block is this, not mu mg. So I hope adjustment of normal reaction should be one of the key focuses for you when you're solving the questions. Normal reaction can be changed by application of external force like this. If I press it downward, right? If I press a block like this, so let's say my block is lying here, right? If I press it like this, my downward force is this. So this is my F, let's say this is theta, right? So this is F sine theta. So mg plus F sine theta will become equal to normal reaction. The normal reaction will go up. So always remember, frictional force is not mu mg but mu n. And n can be manipulated by application of force at an angle. Either push it or pull it. If you pull it, it reduces. If you push it, it increases. So you would have heard that general question of pushing versus pulling. That is where the source of this concept is, right? So I hope you like this video. Please go to my playlist of friction. Fantastic questions given for JEE Mains, AP Physics, IB Board, Excel, you name it. And you will find very interesting questions for you to practice and build your concepts. More clarity results in less stress and better marks. So don't give up on physics immediately getting frustrated. Concentrate on these videos and gradually you will see tremendous improvement in the subject. Thank you very much for your time today and look forward to meet you soon.